Okay, remember the equilibrium constant is always the products, concentration of the products over the reactants. We talked about that last week. So on page 514, 515, 516, when it's talking about acid ionization constants and base ionization constants, don't be confused, it's the same thing. So they put a little A there because it's the acid ionization constant. So this is telling you, remember, an acid donates an H, and so all you need to do is take the concentration of the products, CH3CO2 over the reactants, CH4O2. It's exactly the same thing as before. It's just a different way of looking at the numbers. So if you get a big number, that means you've created a lot of this H+. If you get a big number, that means you have a really strong acid. If you get a small number, that means you have a weak acid. Same with a base. If you have a very high number of products, you'll have a big number because anytime you have a big number over a small number, that means you have more of the top thing than the bottom thing. So if you have a big number, it's going to be a strong acid or a strong base. So just be careful here with your exponents. So let's read 15.7. Nitrous acid has an ionization constant of, so they've already calculated the K sub A, of 4.5 times 10 to the negative 4. And they want you to compare it to an acid that is 1.8 times 10 to the negative 5. And they say, which one is the stronger acid? Well, if you take into consideration this, if you can't see it, move it out. This is 4.5 times 10 to the negative 4. This is 1.8 times 10 to the negative 5. So hopefully you can see which one is a bigger number. The bigger number is going to be your stronger acid. So this one is going to be a stronger acid than this one because this is a smaller number. So just, if you can't see your exponents with the negatives, take them out of your negatives so that you can compare them. Also, you need to know pH scale. So on page 516, the pH is on a scale of 0 to 14. So anything that's 1 or 2, and 13 and 14, anything that has a pH of 1 or 2 is a very strong acid. Anything in here, 3, 4, 5, 6, or 6, is going to be a weak acid. 7 is neutral. So that's your pure water is neutral. Anything that's in here, 8, 9, 10, 11, or 12, is going to be a weak base. And anything that's 13 or 14 is going to be a strong base. So this is your pH, which means potential hydrogen. It's the potential hydrogen scale, but you've used pH before. We've tested for pH before with those little strips that turned red or blue. So they're going to give you the different pHs of things, and they'll say which one is the strongest acid, or which one is the strongest base, which one is a weak base. So just make sure that you know that 1 and 2 are strong acids. 13 to 14 is a strong base, and a pH of 7 is neutral. And anytime you go from one number to another, that means it's 10 times, so something from 7 to 6, this is 10 times more acidic. So then from 6 to 5 is another 10 times more acidic. something that goes from 7 to 8 would be 10 times more basic. 8 to 9 would be another 10 times more basic. It's not just one, it's actually 10 times. So something that is a really strong acid or really strong base, they can both burn you and be very dangerous. So, because they're 10, 20, 30, 40, 50, 60, a lot more strong. Okay, so just make sure you can tell what is a strong acid or a strong base. Best wishes on this next set of tests. I hope you're keeping up. I hope you're staying healthy, and hope to see you sometime. Thanks. Bye.